Hello everyone, welcome back to Interview Buddies. In today's video, we are going to talk about linear regression. If you are looking into machine learning algorithms, linear regression is the very entry point of the algorithm. This is the first thing you would want to learn. So let's get started. What is linear regression? So linear regression is a supervised machine learning algorithm that works on structured data. Unlike supervised methods that find hidden patterns without labels, linear regression uses labeled data. And we will see in a minute how what labeled data means. It's basically think of it as a spreadsheet where your columns are labeled and you have rows are labeled. So that kind of data, you have every variable or the parameter has a label on it. So that's the label we are talking about. I have used two terms here. One is structured data, unstructured data, um, supervised, unsupervised, right? So what is it? So what is structured data versus what is unstructured data? Structured data, as I said, it's like neatly organized row and columns like a spreadsheet or database. For example, your house prices, stock prices, weather data, it's all basically structured. Unstructured data that doesn't fit into the definition of rows and columns, like uh, text images or audio files and stuff like that, right? So that is your unstructured data. What is supervised learning? In machine learning, where we train with the labeled data, that is your supervised learning. So for example, if you want to predict what will be the traffic flow in this direction based on the past history, you can use that using you can predict that using the supervised learning, or the house prices you can predict using the supervised learning. Unsupervised learning is where there is no labels, basically just input and no clear output. So example is uh, customer segmentation, like clustering of shoppers by spending patterns. Right. So before we move on to the next slide, I want to show you how the data looks like. So for example, here. So on this slide, we have the data in the labeled format. We have house size and prices, and if we want to predict the house prices, we can use this label data to predict that. Okay. So that's what label data or the structured data means. All right, so that's a definition of linear regression, and basically, there's a relationship between input and the output. You know the input, and you want to predict the output. So there's a linear relation between the input and the output, and it forms like in a xy axis, it forms a straight line, and we will see that in a minute. So that's what linear regression is. Why we use linear regression? Because it's simple and powerful algorithm. It provides a baseline for many ML tasks. It used in predicting things like house prices, stock values, trends. It helps us understand relationship between different variables. Okay. So common examples and use cases like sales forecasting, like how much sales you made, how much sales you're gonna make in the next quarter, right? You have a stock price prediction. You can use this for predicting the house prices. Patient health, basically how's the health so far, or different trends around that. You can also predict the traffic flow, also like the student performance, etc. So these are like some common examples or use cases that works perfectly fine using the linear regression. Okay, and also it is easy to understand and implement, uh, and it is widely used. It's not like it's very basic, so it's not used. No, it's widely used. So that's your common examples. And what is a general rule when we use linear regression? So when we use linear regression, the target variable is continuous, not categorized, or not categories, right? There's a roughly linear relationship between features and target. And interpretability means knowing why the prediction is made is important. So That's why the this so this is the basically a general rule of using the linear regression. So an example, so we want to predict house prices in your area, and you know input. So let's see the data first. So you know the input, the house size, right? 800 square feet is for 150K, and 1500 square feet is 260K, and so on. So you want to predict the house prices. So you have independent variable here, which is called as X, and the dependent variable is price, because price is dependent on the size of the house. So that's why it's called dependent. So if the linear regression, we will try to predict the house prices, and it's basically a line, and the line is like a slope, and we will use this formula, m into house size plus c. So m is your slope, if you have used linear algebra before. So m is the slope, basically how much price is increased or decreased per square feet, and c is your intercept, uh, base price when the size is 0. So this is the basic formula, and this is the linear regression formula here, mxy equal to mx plus b. So that is the formula of linear regression. If we want to plot these prices, right, dependent versus independent variables, or different data points, you will see a line like this, and you will see all the points plotted in that plot. Here are the takeaways. So linear regression finds the best straight line. It helps predict outcomes based on the input variable. This is useful for understanding trends and relationship, and this is the foundation for advanced ML algorithms. Okay, so now let's go to the demo. All right, so I have this Python file, price prediction. I'm using this pandas sklearn, and this is my data set. It has a square footage, different basically numbers here. It has a price variable, and it has bedrooms, 2 3 4 5, whatever, right? So what we did here, we created a data frame, and we said x, or the features or the variables or the independent variables are square footage and bedroom, and the dependent variable is price, so that is labeled as y. And then we trained the model. So there's a linear regression function in the Python that you can use. It's part of sklearn, and you can call that function, and then you say model.fit. Okay, and then you predict the price of a new house, which is, let's say, 2000 square feet and has 3 bedrooms. And then you say new house is equal to, you basically provide the independent variables there, and then you say model.predict, since the model is trained on this data. And when you pass this independent variable here, it will predict the price of the house, based on the square footage. Okay, and then it will print it. So let's try to run this. So Python, so the predicted price here is 350K, around 350K, and that's what it predicted. So I have another file in which the data is not exactly the same, but it is somewhat similar. So it has a house size and house prices. So just to give you an example how the plot looks like in this case, so we will kind of run this, and we did the same thing, model.fit, model.predict. Okay, and here we are giving the size range, which is in this uh, range, and then we try to plot this data. Okay, so Python sample.py, and you see some of the data points are below the line, and some of the data points are above the line, and you can see the prices that are increasing with the square footage area. So that is your linear regression, and yeah, go play around with it. So in the next video, I will capture other machine learning algorithms. Hope you like this video. Thank you very much.